Now let's do another example. Two charged balls hanging in equilibrium. Suppose two styrofoam balls of mass 10 grams are suspended by threads of length 25 centimeters. The balls are charged, after which they are hung, each at an angle 15 degrees to the vertical. So here are the questions. Are the signs of the charges the same, or are they opposite? Are the magnitudes of the charges necessarily the same? Explain. And find the net charge on each ball, assuming that the charges are equal. So what they're saying is that there are two styrofoam balls. They are hung from a ceiling, right? And then they each make an angle 15 degrees with the vertical, and the length is 25 centimeters. And what they're asking us is, are the charges the same? So what are the signs of the charges, right? So we know that since they are going away from each other, they should be the same charge. So answer to part A is that they are the same charge, but do I know which one? Whether they are positive or negative? The answer is I do not. And the reason is because they didn't tell me how they were charged. They just told us that they are charged. So I don't know whether they are both positive or whether they are both negative. But I do know that they are both the same charge. Number 2. Are the magnitudes of the charges the same? Well, they are each equally distant apart because they are 15 degrees both. But are they actually the same? It would apparently seem like they would be the same, but look carefully. What do I know? I know my Coulomb's force is proportional to Q1 and Q2 magnitude. So now I have F is proportional to Q1 and Q2, but I don't know whether these necessarily are going to be equal or not. They could be, or they couldn't be. I really can't tell. Okay? Now, part C, what does it ask me? It asks us, find the net charge on each ball, assuming that the charges are equal. Okay, so now that we assume that the charges are equal, how can I reuse what I already know in order to solve this problem? Okay, I know that the tension is going to be pointing upwards, right? So if I was to use vectors, how would I do this? So the tension is pointing upwards. I know mg is always pointing downwards. I know this angle is 30 degrees. So if I was to redraw only part of this, this is what that picture would look like. This is 15 degrees. L is 25 or 0.25 meters. I know this is R, okay? I know tension goes upwards, right? If tension goes upwards, then that means tension and tension, the components of tensions go this way and that way. Okay, I can call this Tx and I can call this Ty, right? Okay, now what? If I choose my coordinate system, like a regular one, this is what the coordinate system will look like, x and y. So I can rewrite sigma fx and sigma fy. This would be electrical force that is keeping these two things apart minus t sine theta, and mg minus plus t cosine theta. Since this is not an accelerated frame, sigma fx and sigma fy will be 0. What do I get? I get Fe equals t sine theta and mg equals t cosine theta. Now, what is my job? My job is to calculate what the net charge on each ball is going to be. Where is this going to be located? This is going to be located in Coulomb's law. So I can plug in that value. What do I get? I get K, Q, assuming that they are equal and equal charges, I can assume both of them are going to be Q divided by R squared equals T sine theta, and mg equals T cosine theta. So I get these two values, T sine theta and T cosine theta. I think if I divide these two equations, I can get rid of T. So what I'm going to do is I'm just going to divide these two equations, get rid of T. What do I get? K Q squared over R squared, right, equals mg, sine over cosine is tangent theta. Okay? Now, very careful. This R is the total R separation between this point and that point. So that means it's going to be R1 plus R2. So what is R1 plus R2? So I can call it R12. Okay? So R12 will be R1 plus R2. If this is L, what will this be? L sine theta. And so if this is L sine theta, if I was to extend this further, this would also be L sine theta. So what do I get? R12 is 2L sine theta. Okay? Good. I can plug that into here. What do I get? I get K Q squared over 4L squared sine squared theta equals mg tangent theta. Now I have pretty much everything I'm going to need in order to solve this. So I'm looking for Q squared. So Q squared is going to be mg, right, 4L squared sine squared theta tangent theta divided by K. I have M, they give me M, they give me G, well that's just 9.8, they give me L, which is 0.25 meters, they give me theta, right, which is 15 degrees, and I know K, which is 9 times 10 to the 9. And all I have to do is plug in some numbers and calculate for me. I calculate Q to be equals to 0.22 microcoulomb. Remember, the magnitude of Q. Whether Q is positive or negative, I can't tell. But I can tell that the magnitude of Q is this number.